A fantastic introductory video, which is one of many of the topics addressed by the GESDA radar, and I certainly look forward to engaging in all of the topics besides the one that we are here to hear about today. So greetings to the live audience, welcome, and greetings to the rest of our virtual audience, wherever on the planet you are dialing in from. It's my great pleasure to be moderating today's session on utilizing space resources for collective prosperity at this inaugural GESDA Summit. I'm delighted to be joined in person by Matthias Link, Director of the European Space Resources Innovation Center and Director of International Affairs and Space Resources at the Luxembourg Space Agency. I'm delighted to be joined in person also by Patrick Michel, Senior Researcher at the Observatoire de la Côte d'Azur and Team Leader at Théories et Observations en Planetologie. And we are also delighted to be joined virtually by Niklas Hedman, Chief of Committee Policy and Legal Affairs Section at the United Nations Office for Outer Space Affairs, Tanya Masson-Zwan, Assistant Professor and Deputy Director at the International Institute of Air and Space Law at Leiden University, and Su Meng, the founder of the Origin Space Corporation. Welcome to everyone and welcome to the panelists. So, space resources is pretty much a big topic which can be thought to include everything except Earth. Except Earth is also there somehow. Earth observation data is, of course, also a space resource. So our challenge today will be to fit a very vast array of thoughts and ideas and topics from the vastness of space into the 1 hour session. So let's firstly recall that we're already in space, hurtling around the sun at 30 kilometers per second, our source of energy, the sun, our magnetic field protecting us. And so this indeed is a big topic. The region just beyond our atmosphere has become a resource for communication, observation, and exploration. But our ambition as well as our resource requirements are greater still. So to get further into the mood after that great introductory video, we are going to launch another poll, which I welcome you to participate in. So if you've already joined the first session, you will know to go to the address indicated above and type in the hashtag. Oh, we're seeing the information, good. And we should be able to see the questions. Let's start basically, I'm guessing the audience is a combination of people working in the space industry and people curious to see the state of knowledge and activities in space, also projecting forward on various timeframes. So is the pursuit of space resources a worthwhile endeavor? Let's keep it simple, yes or no. Arguably, we are already utilizing space resources. But what are your thoughts on this? Good, okay. So perhaps some are seeing space resources perhaps as mining asteroids in particular, but low Earth orbit is certainly a resource already for the richness of data, which informs many different industries. So let's move to the next question. Should space resources boost development on Earth or fuel off-world expansion? So I guess this was a tricky one because I would add a third category, which is both. But if you had to be forced to choose one, which would that be? Fantastic. So the majority of us believe that this should be for the benefit of Earth. We have one more question to frame some of the discussion, and that is, should the utilization of space resources be done in a framework of a multilateral endeavor? Or can it be left to liberalism? Again, a binary choice you have there. Fantastic. In the spirit of the GESDA organization, yes, it's going to be a delicate interplay, but certainly multilateralism is thought by a majority to be important in playing a role here. So let's kick off with some discussions. Su Meng, as the founder of China's first company dedicated to the exploration and utilization of space resources, could I invite you to share why you believe the pursuit of space resources, I imagine you believe, is a worthwhile endeavor, what kind of space resources you are interested in, and also to share some details of your company's success earlier this year. Thank you, Sumeng.
Okay, thank you very much. It's a great pleasure to join this forum. I was trained as an astronomer, so starting from the very beginning, I'm very fascinated by the universe. So I didn't actually have an idea about space resource, or actually we can possibly mine asteroids before before I joined Harvard as a PhD student. Professor Martin Elvis taught me that astronomy is no longer a field, just looking at the sky. We can actually observe and capture and utilize materials like asteroids, small asteroids around Earth. So it's my first time learn about it. So since then, I think I have a very deep interest and
Wait a few more seconds. Otherwise, we hope Sumeng can rejoin us. Perhaps sorry, Sumeng, we lost you for a moment from the time you were moving from your transition from research into your current activities. Sorry, you froze for a minute.
Oh yeah, sorry about that. I think very briefly, our company founded 2 years ago. So actually, aerospace, the whole field of aerospace, only opened to market in China about 6 years ago. So our company is still the only company our long-term goal is to discover, explore, develop, and utilize space resources such as metal and water from near asteroids to better serve the space industry. And we have the hope and have the belief that it will not only change the way we explore space, but also will pave the road for future space industry and change our life on Earth. Our company was founded by a quite international scientific team and a senior aerospace technology team. Although we only founded about 2 years ago, we have launched 4 satellites into space already. So our company named Origin Space, so why call Origin? Because we believe that asteroids will basically keep the most original information about our solar system, but they will not only tell the history, not only tell us a scientific knowledge about our solar system, but also lead the future of human beings in space and also on Earth. So we want to make influence on the community and motivate people to have the better vision about space resources. So that's kind of what our company's job. We hope to promote the field. So very briefly, this year we launched 2 satellites. One aimed for discovering more near-Earth asteroids. I think it has been not our idea, but we hope to build a cheap satellite or space telescope and make it fast. So we launched optical and UV telescope, and next year we will have an infrared telescope to observe in multi-wavelengths different asteroids, near-Earth asteroids. So that's one pathway where we basically want to launch a space telescope constellation to small ones to cover more areas of the sky, so we can alert people when some unknown asteroids coming to Earth for a protection purpose or for research purpose. And also another satellite I would like to briefly mention is that although we cannot capture asteroids today, but we want to mimic what kind of technology is most suitable for future missions to capture small asteroids. So we launched a small one to basically release a net to. So first we release a object to mimic asteroids. Then we release a net to capture it with a string connected to the satellite, so it will not become a space debris. So we basically try to make technology demonstration for this kind of so there's one way to capture asteroids for future purposes. So that's it's a very small step, but we hope to promote the technology, and in the near future we can actually go into asteroids. So we plan to go to asteroids within 2 years, so we can go to very closely to look at the asteroids and test whether this technology works. So our plan may change. It depends on how we can develop these related technologies. But I think it's a very it's the best thing we can do. We have tried our best to make small steps. I think we can always make small steps, and people can see this field is growing, and this field has some activities. So that's kind of the background of our company. Thank you very much.
Thank you so much. I'm curious, so certain companies, based on the US passing of the act allowing private companies to retain and own resources that they extract in space, some of the companies established in this excitement of 2016 around then, things have not turned out so well for all of these entities. So I'm curious on the debris that you have mentioned. Is this part of a commercialization strategy for Origin Space? Or how will you manage to overcome the challenges that companies like Deep Space Industries and Planetary Resources were facing from the commercialization aspects? Please go ahead, Sumeng. Have you faced similar challenges in this? Is space debris going to perform some kind of bridge from the asteroid activities that you are planning to your current activity?
Yes. So this is actually exactly the I wouldn't say it's a business model because no one is paying for the debris removal. But I think what we are doing right now is to pave the way for technology development. So with a small satellite, you can capture some reasonable size debris which has potential danger to it's a problem, and it's a well-known problem. I think people sitting in the conference room all agree that it's a problem, but we have not really figured out a policy and a whole structure to clean up, or at least so first stop producing more space debris for under certain policies, and we need to clean up the space environment at different orbits, which is becoming more and more serious problems. So I think related technology which we are developing, for example, looking at the sky with large areas, we do sky surveys. We do sky surveys to monitor and discover near-Earth asteroids. With these monitoring space telescopes, it's actually telescopes for astronomical observation purposes, but we can see more debris. So we can provide, the parameters of these orbits of, different known or unknown debris of small pieces. So we can have more information to make catalogs of these small pieces. So for future or for other governments or for, the different organization to make plans. So we actually, at least we know what's happening, going to smaller objects, less than 10 centimeters. So that's one way to have more eyes on the sky. While observing asteroids, we can observing, debris. And on another hand, asteroids is much more difficult to capture and to operate than these, pieces in low Earth orbit. So I think on the way to, build up our capability to utilize space resources at large scales. So we certainly will have the capability, related technology to maintain or actually clean up the near environment. So, but how to do it? Who will do it? Who has a capability and right to do it? It's very, it's a big question. It's not. I don't think anyone has a real solution for this problem. But I think we can get ready as a company, a small company. We can get ready, and we can, make voice and make suggestions to policymakers. So that's what we can do.
For sure. For sure. Thank you, Sumeng. I hope somebody will pay you for that task. I think the hazard mitigation aspects of space resources and space exploration is something that we need to put more priority on, whether it's debris collisions that can take out telecommunications capabilities, or indeed asteroid impacts, which we know have caused mass extinction events in the past. So this is a fantastic segue to our next question. Which can perhaps address some of these uncertainties around legislation. So since the first satellite Sputnik was launched in 1957, there are now over 7,000 individual satellites in orbit around Earth, providing, of course, critical resources for a range of capabilities, from communications to understanding climate change and our human impact on the environment. But Earth orbit is getting crowded. Niklas, could I turn to you? Whether we are looking to outer space or closer to home in Earth orbit, what is the state of the art of regulation? What are the challenges? And what role can or should multilateralism play here? Niklas.
Yeah, thank you, Adriana. Thank you so much for that question. I will respond to your question by making a bit of an observation, really dealing with the matter here on space resources. So the crux of the matter here is that we are dealing here with novel activities that will be taken on outside of national jurisdiction, and therefore it becomes a matter of governance, where it is important, obviously, to look into the interest of governments, their own interests, even geopolitical interest in that regard, the interest of commercial and private sector that is growing and becoming more important for this new endeavor. And lastly, the interest, obviously, of the scientific community. That is also something that needs to be taken into account. So we have two main treaties in this regard. I'm not going to list all the international regulations here, but the two main treaties is the Outer Space Treaty, which is binding upon 111 states parties. And I'm not going into a customary international law mechanism here, but let's say 111 states parties, among them all the major spacefaring nations, are binded by the Outer Space Treaty provisions. And then we have the Moon Agreement, which only has 18 states parties, and that agreement is only binding up on those 18 states parties. What is interesting here, and this is the fundamental provision in the Outer Space Treaty, is Article 1, and I will just read a few lines. The exploration and use of outer space, including the moon and other celestial bodies, shall be carried out for the benefit and in the interest of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all mankind. So the challenge here is that we are looking into a growing area of extraterritorial application. The only experience we have in terms of extraction, utilization of natural resources is on planet Earth. And there we have a range of international regulatory systems on how to deal with the utilization of natural resources in areas beyond national jurisdiction. So that is an experience that we have, but we don't have an experience yet on the utilization of resources, natural resources in outer space. Now, taking all this into account, it is encouraging to note that the legal subcommittee of the Committee on the Peaceful Uses of Outer Space, which, by the way, is the prime global intergovernmental body dealing with the peaceful uses of outer space. So the legal subcommittee set up a working group earlier this year, and during the most recent COPUS session, the main committee, only a few weeks ago, this working group adopted its terms of reference and method of work for a multi-year work plan covering 5 years, devoted to the exploration, exploitation, and utilization of space resources. So here we see that states members of the committee, and they are 95 now and will become 100 next year, they are committed to deal with the issue of utilization of space resources as part of a multilateral dialogue. And that is, I think, very important to see that the world community is coming together and treating this matter really as a matter of governance. Thank you.
Thank you so much, Niklas, and great to hear there's progress on these discussions, even very, very recently. In terms of, well, let me move to Tanya. Perhaps some of you are familiar with the American TV series called Space Force. So the first season ends very dramatically with the mutual sabotage of the 2 bases that are on the moon. This is a TV parody, but perhaps hilarious for all of the wrong reasons. Tanya, in your range of capacities, including as an arbitrator for space-related disputes, what are your thoughts on avoiding such a scenario? And could you share your thoughts on the moving from low Earth orbit to the Earth-Moon system? What are your thoughts on the lunar legal landscape in the context of anticipated human presence on the moon and the associated extraction of resources there on perhaps a shorter time frame than we may imagine? Tanya.
Thank you, Adriana, and thank you for having me in this GESDA summit. It's very important to make the international community aware of the plans that are existing, that have been in existence since a couple of years, and many plans that are to come. And we've seen that this is a difficult new endeavor of humankind, but it is also an important one, and it is in line with what the founders of the treaties that Nicholas just referred to wrote in the preamble of the space treaty, of the Outer Space Treaty, saying that recognizing the great prospects that outer space is opening up for humankind. So it's up to the legal community to also frame a solid and legitimate framework around those activities for the scientists and the engineers to develop the technology, and for the legal community to reach consensus on how to do this. And of course, this is an area where there is room for potential disputes and conflicts, because here we are talking about commercial interests, and that is of course a difference with perhaps the exploration period that we have been into in the first 50 years of the space age. So definitely the potential for friction and conflict is there. So far there have not been any major disputes in space exploration, and that is, I think, a tribute to humankind, which realizes that cooperation is the way forward. And you see that most countries that are bringing missions to the moon or asteroids, whether it is states or in cooperation with private entities, everybody realizes that this should be a joint effort. And so it is essential that indeed bodies like the UN COPUOS that Nicholas represents here reach consensus. That is the way to forward to reach a common framework. And there are several guiding principles that everybody should, I think, keep in mind. For instance, that we should do this in a way that we preserve the long-term sustainability of these space activities, so that also future generations will indeed be able to make this step towards permanent human settlements, perhaps on the moon or on Mars. And for that, we will have to take into account also environmental aspects. You mentioned debris earlier, sustainable development, planetary protection. All these elements have to be framed into a regulatory system. And basically, to avoid this conflict, I think it is important to go step by step. And a theme that I have often used in work in this field is adaptive governance. We should try to regulate what is going to be feasible, possible in the medium term, and not look at the longer term. Of course, Sumeng explained about catching asteroids and so on, which is very exciting, but maybe really more in that 25-year time frame. And we will have to deal with that then, because is that allowed under space law? I think I would pose some questions, and I guess Nicholas might agree with that. So this is in the immediate term, we have to look at how to involve those private entities, the new stakeholders, which currently do not really have a seat at the table in the United Nations. How do we make sure that their interests are also represented? How do we make sure that we have that collaborative framework? We see currently a two-track approach, and that worries me a little bit, with one set of countries working on lunar exploration, and then another set of countries working on another grouping of states to conduct such projects. I really hope that in that 10-year framework, we can work towards a consensus on a strong regulatory framework that sets common standards for the benefit of all humankind. And I think I'll leave it to that for now. Thank you.
Thank you so much, Tanya. Yes, I love this concept of adaptive governance. I suppose that is all we have essentially with such rapid developments happening from so many different sectors. But let me move to our live guests. And in terms of anticipating developments on this topic, while we were creating the reports and information around the radar, we were looking at 5-year, 10-year, and forced to even consider 25-year horizons, which becomes quite subjective at some point. But moving to a 5-year time frame, Matthias, if I could ask you. So the Luxembourg Space Resources Initiative and ESREC were established 5 years ago, 2016. So looking back at the strategy that was produced in 2016 and the rate at which things happen predictably or not within that period, do you have any lessons to share on the next 5 years? So looking at the most reasonable time frame of 5 years. And maybe you could also explain some specific details about the space resources topic. What exact resources are you referring to within this strategy? Thanks, Matthias.
Yeah, thank you, Adriana. Very nice to be here and to participate in this debate. So indeed, in Luxembourg, we have been looking at this topic since a dozen of years or so. And of course, we prepared the launch of our Space Resource Initiative in 2016, which we launched with the intention to promote the peaceful exploration and utilization of space resources for the benefit of humankind. And maybe it's good to recall why we are actually considering using space resources, because there's of course a lot of talk about mining golden asteroids and bringing these resources back to Earth, but actually the much more important and more immediate need is to use these resources in space. And maybe I just take a few minutes to recall what this actually means, because when we talk about space resources, we talk about gases, about water, about different metals, but also about regoliths that you find, for example, on the moon or on Mars or even on asteroids, to actually do useful things, useful applications, for example, for the life support of astronauts in terms of oxygen or water, or for example, in producing propellant for refueling satellites or rockets on the moon, but also in low Earth orbit. For example, for building habitation for astronauts or radiation shielding for astronauts, or for building equipment in space. And then from building equipment in space, you can of course think about building larger antennas that will benefit then also applications from the current space industry on Earth, like telecommunication, navigation, Earth observation. You can think about producing larger solar panels, coming to things such as solar power from space, which was mentioned. So it's really important to understand that this is about using resources in space, in the end, to allow further exploration, further science in space, and to also further develop the space economy that we already have in space. So it is with this in mind that we launched our Space Resource Initiative in 2016, and that we have very much engaged also with the international community since then. Now, recognizing the different challenges that you see, and some of them were already mentioned a lot, like the legal and regulatory challenge. This is, of course, one major challenge that needs to be addressed. But then you also have the technological challenge, which where you have to mature a lot of different technologies to make this feasible. You have the financial challenge. This will cost a lot of money, and governments and space agencies alone will probably not be able to fund all of this. And then for private companies such as Origin Space, of course, you have the challenge that you are trying to enable business models with markets that do not yet exist, that we see coming, but they do not yet exist. So all in all, there are different challenges that need to be addressed. And indeed, the way to address these challenges, and that's also the approach that we took in Luxembourg, is to go step by step. As Tanya said, this step-by-step approach is not only relevant for the legal and regulatory domain, but overall to address all these challenges, whether this is on an international level, a legal regulatory level, a research and scientific level, an education level as well, because of course we want people that work in this future sector, and also on a financial level. And it is with this in mind that we launched our initiative 5 years ago. Now looking back, I must say I'm really astonished how fast things have moved, because 5 years ago, this was really a very niche topic. It was, of course, it was already known in the community, but it had not a lot of publicity. And I would say one of the first moments where it really became public is when the US enacted their own law on this. And then, of course, the international community saw, well, this is something we should maybe consider. And then very quickly after, we also adopted a national law in Luxembourg. And the topic then became more and more relevant at the level of the United Nations. And as mentioned by Niklas, this has now been recognized by the establishment of a dedicated working group at the level of the United Nations, which is indeed a major step, recognizing that this needs to be discussed, and that in the long term, we will need to have a framework to organize all of this in an international level. But that's the legal and regulatory level. But on the other topics that I just mentioned, there have been progress on all levels. And there are more and more countries interested by this, more and more private companies interested by this. There has been some evolution also in the technology. To give one example, NASA just extracted oxygen from the Martian atmosphere just a few months ago, which is actually the first real space resource production on Mars. And then maybe one additional information, of course, is that we saw plans, now very concrete plans, to establish a permanent bases on the moon. We have the Artemis program of the US with different partners. And on the other side, we have the Chinese and the Russians that have also proposed their own version of this international base. And all of this is coming. So looking at the next 5 years, this is definitely coming. It's not now a question of when or whether it's coming. It is definitely coming. Of course, we will see how fast it will happen. But looking back, it is definitely going to be much faster than most people expect. And maybe also to give you an idea, a more general idea about what space agencies have planned, there is this grouping that maybe some of you know, the International Space Exploration Coordination Group, which is a grouping of now 26 space agencies worldwide, and all the major space agencies are part of this group. They agree on a roadmap for the next decades of what is to come. And 5 years ago, this roadmap did not mention the use of space resources. Now, 5 years later, it is actually part of the overall architecture of the mission planning, with first ISRU, or space resource utilization demonstrations on the moon planned now in the next few years. And then looking towards the next 10 years, really starting to have little production units for the production of oxygen, of water, of propellant, of metals on the moon. So all of this is now really fixed in plans, and I have no doubt that this will actually come.
Thank you, Matthias. So what an exciting time for space resources and all of the activities we see on the horizon. But it seems like this discussion has to happen in the kind of platform provided here by GESDA, in terms of the delicate balancing act between the commercial interests, the issues of governance and regulation, and issues of fundamental research. So last but not least, single asteroids may contain quintillions, quadrillions, whatever word you want to put, of dollars of metals and minerals. And a lot of initial excitement around the commercialization of asteroid resources didn't end so well for some countries, as I did mention. Patrick, as a specialist of the physical properties as well as the collisional and dynamical evolution of asteroids, and your work in this, which has happened since decades, and your seminal paper in 2001, I understand, has recently been validated by this very exciting era where we are bringing back samples from asteroids from the moon Phobos of Mars. Perhaps even before we bring back samples from Mars, we may have indirect samples from the surface which have been deposited on the moon. So a very exciting time of this intersection with fundamental research and all of the other activities. So what is our state of the knowledge, and how does this impact our endeavors to utilize space resources in terms of understanding the composition? And what kind of timeframes do you have in mind for what we've discussed?
Yeah, thank you. Well, thank you for inviting me first. Yeah, it's an exciting period for asteroid research, effectively, because we have a lot of space missions going or returning samples. I like the approach of Sumang. I mean, his business plan, you understand that it will take time because space is hard, and these bodies are still in the era where we try to understand what they are. So you cannot do immediately business, and therefore the fact that he tries to apply what he's doing for other things and developing the required technology to then mine them, I think is a good approach. We cannot go too fast. However, the good thing is that academical institutions like ESA, NASA, JAXA are providing the knowledge that will be essential in order to be able to cope with these bodies. In fact, in 2016, I remember when I visited also Luxembourg, we were still in the era where we didn't really know how complex these bodies are. And that's why probably some industries so they could do it faster. And then we were also at the stage where there were not that many missions in the programs of the different agencies. So now we have two fantastic missions, OSIRIS-REx by NASA and Hayabusa 2 by JAXA, that visited two carbonaceous asteroids. And that's absolutely crazy because I'm the honor to be a member of these missions. And when we received the first images of these two worlds, we really, all our assumptions were basically wrong. And that proved that, you know, we are going to very, very different territories than the one we have on Earth because the conditions are different. These bodies are very small, therefore their gravity is also very low. And we still have a problem to understand how a surface responds to an external action in a different gravitational environment than the Earth. So in fact, we have two problems with the asteroid, but we're going to solve them. So on the long run. The first one is when we observe them from the Earth, we have very, very few data, which are the ones that are relevant for mining. In particular, what are the surface properties? Are we dealing with bare rock? Are we dealing with gravel, sand? And what are the mechanical properties? And then the second one is that even if you know that, the way it reacts in a different gravitational environment than the one on Earth is totally counterintuitive. And fortunately, and that's why I say, you know, there is hope, because we have these missions paid by public agencies because they are devoted to science, we learn. And what we learn with OSIRIS-REx and Hayabusa 2 is that, at least for these kind of objects, although they look like solid objects with rocks, pebbles, etc., when we touch them, it's like we are going into a fluid, basically. So that's, for instance, OSIRIS-REx took a sample of an asteroid which is about 400 meters in size. First of all, one thing important is the navigation problem, because if you want to mine, you need to land on the asteroid, or if you want just to grab, like we did with OSIRIS-REx and Hayabusa 2, do a touch and go, but you have an accuracy of your navigation. And tell you, for Hayabusa 2 and OSIRIS-REx, the assumption that we should see an area which is at least 50 meters wide to be able to land. And in fact, when we arrived, there was no area that big. And so we had to look for suitable ones. And at the end, we only found a 10-meter wide area where we could land. So they had to revise entirely both mission, their strategy of approach, noting that we are 300 million kilometers away. So it's not so easy. And they succeeded. So that's why, and when you see the Japanese made the first sample return mission called Hayabusa, which was an Indiana Jones adventure, because at the end it came back. So it's a hero, but many things occurred. And they learned from that, because I was following Hayabusa, and we had the journal, daily journal with all the problems. And then Hayabusa 2 and all these problems were removed. So they learn, and that's why the mining company can benefit from that. So the first thing is effectively the navigation and the assumption you do about the smooth terrains with respect to border, etc. And then the second one is how the surface will react effectively, because even if you want to land and let's say anchor because you want to dig, because if you want to dig because you have no gravity, just digging, you go up and you become a space debris. So you need to take an harpoon, but what is the design of your harpoon? Depends on the rock, and you don't know that in advance. So you have to do assumptions. And at least with this kind of missions which interact with these bodies, then we feed these people to better know how to design. And for instance, now we know that for this kind of carbonaceous objects, because both reacted the same, they really, behave like it was a melting butter, just lack of resistance. When we took a sample, it went through the asteroid, actually. Fortunately, the thrusters came and then it came out. And the Hayabusa 2 made an impact, launched a projectile at 2 kilograms at 2 kilometers per second. And the crater was so wide that the only way to explain it is if we remove cohesion from the system. So these are information that the mining people need. And we'll have another experiment, which is will be launched in November, which is a DART mission, which will then be accompanied by the Hera mission by ESA. So DART is NASA mission, and that's devoted to deflection. So it's a first deflection test. But of course, DART will do a crater because the deflection is a kinetic impact technique. So we shoot on the, I shouldn't say shoot, but we impact on the small moon of a binary system. So in asteroid population, we have the equivalent of the Earth and Moon in small scale. And the Moon is 160 meters wide. And then we will make an impact. And later, Hera will come and measure all the properties of the crater, including the composition. So we will know what is in the subsurface of a different kind of body than the one explored by Hayabusa 2 and OSIRIS-REx. So we'll see whether the crater is still, due to a lack of cohesion or whether there is strength. And then we'll know the composition. So, and then we have two other missions. So the Luci mission, which will be launched next week, actually, the 16th of October from Cape Canaveral, that will go to observe the Trojan asteroids. So if we plan to go far away and use these bodies as gas stations, we need to know what they are made of. And as I said, it's not obvious from the ground, and getting a sample back from Trojans which share the same orbit as Jupiter is a challenge. However, if we can go there, try to understand what they are, then maybe we can use them as gas station. And finally, there is a Psyche mission, which is also by NASA, that will visit a metallic object in the asteroid belt, which may be a remaining core of a protoplanet that was disrupted. So again, for the metal, that's also interesting. So just to say that this asteroid thing benefit from a lot of missions that will allow feeding the people who want to do mining. And that's the good thing with asteroids, that whatever the reason why you study them, whether it is science, because effectively, as Sumeng was saying, they are the best tracers of the solar system history because they contain the memory of the original composition of the ingredients that form the planet. The planet are too big, they cooked. It's like a piece of cake and you don't know what is the recipe. So the asteroids are basically the ingredient of the recipe that made the cake. So by studying them, we go back in time. Then there is a second thing, is planetary defense. We want to see how we can deflect them. And then we also have to identify the threat. And then you have mining. And in fact, whatever the reason, you need the same knowledge. What are they made of and how they react to an external action? So that's why it's very interesting that we have different agencies or companies going there, because the information will feed these different communities. So that's good. And for the last thing I want to say is that effectively using asteroids for resources on Earth, maybe in some centuries, but personally, I think it's very difficult because OSIRIS-REx, for instance, we get back at least 200 grams. I won't say the exact cost, but it was several $100 million for a few thousand grams. So I'm not sure the best business plan is there. The other mission was to capture an asteroid and to bring him back to a cislunar orbit. And again, the more you are expert, unfortunately, the more you know you don't understand. And that's where it seems simple for the non-expert, but it's more complicated for the expert. And I want to discourage, it's good to have objectives and try it. I don't think in the long run it won't work. And as Sumeng was saying, we are doing the step-by-step approach. But just to tell you, when you think about a 7-meter object, for instance, in space, and you want to capture it, so you have two problems. The very small asteroid, they spin very fast, less than a minute. So if you want to capture, you have to despin. I don't know how you do that. And second, we understood with OSIRIS-REx and Hayabusa 2 that they are extremely sensitive to the level of cohesion that they have between the components. And even 1 Pascal make a difference. 1 Pascal is just like if I put a leaf on my hand, that's 1 Pascal. And you change the value by 1 digit and the thing is not stable. So just to say that when you touch them, you don't really know what it's going to do. So I'm not saying it's not possible, but it's risky, and risk means cost. So you have to be prepared to spend some money if you want to use this approach in order to know how to do this. So this has to be taken into account. But I don't discourage any initiative, of course.
Fantastic collaborative spirit. So we've got 10 minutes left, and I'd love to get some inputs from each of the panelists. Are there any questions from the audience that we can address in the meantime? Any online questions that have come through? If you're still thinking about a potential question, let me allow each panelist a couple of minutes to close off, or do we have a question?
Yes, we have an online question, which is, how do we address equity in access for global utilization of these resources? And how do we avoid furthering the financial gap between countries, I assume, that enter in this race for space resources utilization?
Okay, fantastic. Perhaps what I will do is ask each panelist to address this question of whether we propagate inequality or not through access to space resources. But if I can give the challenge to the panelists of also addressing essential parts of the GESDA initiative, which is action. So what are the priorities for action now? And I think we've heard since the opening sessions yesterday that, the pandemic we're in the midst of has highlighted, if not exacerbated, existing inequalities. And this is a center of discussion, whether we're talking about space or vaccines. So perhaps this is a good combination. If we could run through the panelists, talking about action in your mind, what are the priorities of things that maybe we are not doing enough of now that we need to focus on? And if you would care to address how this speaks to inequality or minimizing or mitigating inequality. So let's run through and start with Sumeng, please. Sumeng, any closing statements on the priorities for action?
Left.
All right, Niklas, over to you.
Yeah.
What are the most pressing priorities from your perspective?
Thank you, Adriana. First, just a comment I think is quite important in this regard, and that was what Matthias brought up. What is the purpose of space resource utilization? And that has to really be taken into account in this multilateral discussion we're seeing, because I don't see any potential, I would say, in principle, any issues with the resource extraction. It is the way how it is done and the purposes of it, and mindful of the fact that we are dealing with activities outside of national jurisdiction. Now, this is a very fast moving area, and in terms of governance and regulatory aspects, it's only in a couple of years, only maybe 5 years, that we have on the table kind of really a good collection of already well-formed building blocks and basis for further discussion. And I'm here alluding to the Space Resource Governance Working Group that Tanya was working on for some years, and which is formally put on the table of the legal subcommittee. And that contains a lot of answers that we answers to the questions that would be important for the legal subcommittee working group to now start assessing. And there are other examples also. So the intergovernmental community already has kind of an built up background that they can draw upon. And now it's the matter to see how states are going to put this together in a consensus achievement. And I think it has gone very fast, only a few years. So I'm hopeful that in this span of the next 5 years of this working group, there will be something coming out of that effort. Thank you.
Thank you. Thank you so much, Niklas. Tanya, can I invite you to make some closing comments?
Yes, sure, Ariana, thank you. Yes, this is a fascinating discussion. And if I look at the next 5 years, for me, the most pressing issue is that we manage to provide clarity on some issues that are not clearly addressed in the founding treaties that we have. And that's understandable because that was not on the mind of the drafters. And just to mention a couple of examples that go both to protect and promote the interests of the industry, but also of humankind. We need to, for instance, clarify whether certain safety zones around operations are allowed and under what conditions they can be installed. We need to also assess whether we can have a system of priority rights of companies that are going to invest financially and technologically. They need to have their interests protected by certain priority rights, by a register of mining plans, for instance. That is not yet foreseen. On the other hand, we need to make sure that we find a way to fulfill that legal obligation that space activity has to be for the benefit and in the interest of humankind. How do we translate that concretely in terms of involving not only the pioneers, but also emerging countries? And lastly, perhaps, how do we make sure that we also protect the celestial bodies that we're planning to mine in the environmental context? We have certain rules about orbital debris, but there are no rules, and they're not even legally binding, but there are no guidelines for how to deal with stuff that we leave behind on the moon, or rovers and waste and so on, and we will need to have some provisions for that. So those are my hopes for the next 5 years. Thanks.
Thank you so much, Tanya. Matthias, from your perspective, I suppose priorities for action that maybe we are not doing enough of at the moment.
I think it has already been mentioned by Niklas and Tanya very well. Indeed, I think we know quite well what are the areas that will need to be refined. And I can indeed also recommend the outcome of this Hague Space Resource Governance Working Group, because it's an easy, quick read, and it shows the complexity of this whole domain. And indeed, it's all about, as Tanya said earlier, about adaptive governance. So we need to go from these basic elements that we know need to be addressed. We need to go one step further. And going one step further, unfortunately, cannot be only on a paper and in a purely theoretical manner. I think Patrick really well explained the issues related to asteroids. There are similar issues on the moon and on Mars. And in order to solve these legal and regulatory issues, we also need to see very practically on the ground what does this actually mean. And that's what I said before. In the end, there's not just one single challenge that needs to be addressed. We need to progress on all these different things in parallel and step by step, seeing what are the actually technological challenges that we will face, what is actually going to happen on the surface of the moon, what kind of operational issues will we face. And of course, all of this is complex because you have the private industry that is more and more interested in this, and you have also more and more countries that are interested. And in the end, it all will only work if we sit together, we speak together, we address this all together in formal groupings like at the United Nations, but also in informal ones where you can really have a very open discussion also between the private industry and the academia. And the good news is that this is actually really, this is happening. It would take too much time to go now into the details of all these different fora that have been set up, the different conferences that deal with this. But this is of course going to continue, and in the end, we will find a solution also to address all the different aspects that have been mentioned by Tanya and by Niklas.
Thanks, Matthias. We have 1 minute, and
Yeah,
I think in terms of action, you have certainly described a full of activity agenda on your side, but some closing comments on priorities for action.
Yeah, I think what's important for me is that the academy works with the private, because at level of space agencies, I could observe that they are very reluctant to take any risks. And in fact, we need to take risks because we are still in the era where we explore. And the fact that companies like Space Origin are willing to take those risks, I think is good, and we can move on together because we have the expertise and we know what needs to be known, etc. And they have the courage and the initiative to take the risks. So if we can do that in parallel, both, I mean, we have academic mission and private mission and talk together, for sure, it will move much faster. I really encourage that. And I think it's great that there are some companies taking those risks and looking for what seems impossible, that at the end they can do it because they take more risks, so they move faster.
Fantastic. So take risks. And Sumeng is back. So can I please invite you?
Sorry, my connection was.
Any closing statements? No, thank you.
Yeah, I think the field is moving very fast. As Matthias mentioned, 5 years ago, it was little coverage in public about space resources. And these days, I think every several days, there is some kind of news about space resource development. And also, for example, Luxembourg Space Agency published the space resource report every other month, I believe. So I think this field is really moving fast. So I'm very optimistic about what would be done in the next 5 years and 10 years. I think that nowadays it's becoming more well-known concept. So space resource is no longer a science friction for most of the people. When I talk to these Chinese investors, so a few years ago they think it's basically just a story. There's no business any possible business model about it. But I start to launch satellites, start to get things done, they actually do their own research, seeing the international outcomes. They know space resource is the future. So it's going to happen, just a matter of how it's going to be done. So I think the next 5 years is a very, very different period for this field. So I'm very excited about it.
Thank you. And we are right on time for closing up. I think many industries have been brought to their knees during the past couple of years. The space industry is not one of them, it seems. And that's a good thing because our continued existence on this planet and others will rely on our knowledge of reality also beyond Earth. So we've only had the chance to scratch the surface of this topic. So let me finish off by saying, as Canadian philosopher Marshall McLuhan so beautifully put it, there are no passengers on spaceship Earth. We are all crew. So whether you are active in the space resources industry or thinking about the future sustainability of our society here on Earth, space gives us a broader perspective of reality and our place in it. Thank you very much for joining. That's it for today, but I'm sure we can continue the discussion in the breaks. Thank you so much.
Thank you.